Hi everyone, my name is Luisa Barros and I am going to present the work made by my colleagues Mari Barreto, Lucas Pereira and I, entitled Understanding the Challenges Behind Electric Vehicles Usage by Drivers, a case study in Madeira Autonomous Region. There is scientific agreement that humanity is contributing to climate change through the emission of greenhouse gases. The reduction of greenhouse gases emissions to the atmosphere is stated to be strongly dependent on the implementation of governmental incentives and policies in different sectors. Electric vehicles are considered to be one of the greatest options for the reduction of CO2 emissions on the road transportation sector by increasing the introduction of renewable energy sources into the sector. However, renewable energy sources are known for being vulnerable in terms of the uncertainty of weather conditions. Hence, it is predictable to schedule charging EV batteries when RES are available. EVs are increasing in Madeira Autonomous Region, RAM in Portugal. RAM includes two inhabitant islands, Madeira and Porto Santo Island. A major concern for EV technology potential buyers is the charging time of EV batteries compared to conventional vehicles. CVs with internal combustion, such as diesel or gasoline. There are different approaches when it comes to modeling the charge and discharge of EV batteries, load management. EV batteries can be influenced by several factors such as battery state of health, temperature, seasonality, integration of renewables, the household charging incentives in order to reduce the cost of EV chargings, the availability of public charging stations, and others. Usually, this battery management not only tends to decrease the time available for EVs to charge, but also may increase the time of EVs charging. Furthermore, the mentioned approaches may not likely be implemented in particular cases, as there might be circumstances where EV users' liking may overlap the overall options to model the EV battery load. So, we started to review the literature about users' perspective of charging EVs, and we found that from users' point of view, charging electric vehicles can be split into two main thematic extents. Users' charging behavior in terms of dealing with the EV range and battery technology from a psychological point of view, and second, users' demand on charging infrastructure along with the decision processes for the selection of charging stations. Regarding the first topic, several studies pointed out that practical experience with EVs can change users' perception and experience of limited range. It is claimed that the expertise plays a key role in exploiting the potential vehicle range, arguing that as the experience with EVs increases, the range anxiety decreases, increasing the user's range satisfaction. For EV users, it is stated that EV drivers have to face a different type of driving conditions compared to conventional vehicles. EVs have a regenerative braking system, RBS, which it converts kinetic energy into electric energy during deceleration maneuvers. Besides the existing difference in the RBS between EVs, generally it is mentioned by the literature that the RBS serves as an energy-saving system and increases the range of the EV. However, the findings that were tested from EV user samples facing the RBS system used poor track conditions, example, testing simple oval tracks without other cars on the road, any light traffic or difference in the orography of the track. So it is needed to provide more information about the functionalities and potential of the RBS and consequently for the battery energy savings. The second topic regarding users' perspective about charging the EVs are the reasons behind users' choice of charging infrastructure, example at household, at work, or at public charging stations. Authors from the literature affirm that EV users prefer to carry out the majority of their EV chargings at households. EV users' favoritism for charging at households are justified with diverse reasons, such as the seldom availability of public charging stations, the costs associated with using public charging stations, preferring low-cost EV chargings, and ultimately their own comfort and convenience. In Madeira and Port Santo Islands, there is a particular case to what concerns the charging EVs in public charging stations, which is EV users don't pay to charge their vehicles at public charging stations. In other countries, charging EVs at public charging stations is more expensive than charging the EVs at households, not only for the fact that fast chargers require expensive equipment, but also because of the maintenance and management additional sources. So, concerning those aspects previously mentioned, it is the moment to present the research question and hypothesis of our study. Research question number 1. Does the economic factor influence the location where the users charge their EVs, or is the commodity of charging in the household still predominant in RAM as found by the literature review? So our hypothesis to answer this research question number 1 is the literature review reveals that EV users prefer to charge their EVs at their households. However, with the specific case of RAM, users do not pay to charge their vehicles at public charging stations. Thus, in this part of the case study, users may prefer to charge their vehicles at public charging stations. Research question number 2. Does the orography of Madeira Island influence users' charging behavior in terms of dealing with EV range and battery technology? The hypothesis number 2 is there is no consensual agreement among EV users about the potentiality of EV technology, more concretely the usage of the RBS, the regenerative braking system. Hence, it will be studied users' opinion about RBS and if orography influence users' behavior about battery autonomy. To conduct our study, we defined the target sample, which are EV drivers from Madeira and Port Santo Islands. We built an electronically fully structured interview, an online questionnaire made on Google Forms. The sample was approached with the link of the questionnaire that was disclosed on different social media platforms. This sample was selected using a snowball sampling method, since it was based on the EV drivers' voluntariness to fill the online questionnaire. Moreover, the participation was anonymous and no compensation was given to participants. The data collection was carried out from November the 24th to December the 12th of 2019, so 20 days. The online questionnaire was provided in Portuguese with open and closed-ended questions, but the majority of the questions consisted of multiple choice and Likert scale. The procedure of the online questionnaire was divided into 10 sections that are here described, and I'm not going to extend this part. So, regarding the analysis, non-parametric tests were used due to the sample not following a normal distribution, and the level of the significance was set to alpha equals to 0.05, and a two-tailed test was used. To answer research question number 1, the main infrastructure users charge the EVs, the Kruskal-Wallis test was used. Since the data of the questionnaire is ordinal and three groups were being compared: the household, work, and public charging station groups. Additionally, to study the reasons why users prefer to charge on a specific infrastructure, it was examined whether there is an association between two categorical variables. In this case, the profile type of users, the location of variable where users mainly charge their EV, and each dependent variable. The dependent variables, in this case, are a group of 4 linear scale questions with variable names faster, cheapest, comfortable, and public charging SOS. A pairwise comparison between each profile group of users was also made when a significant effect was found in Kruskal-Wallis test. Spearman's correlations were used to measure effect sizes of variables comparison. To answer research question number 2, the effect of the orography, it was necessary to take into account two sample groups were going to be analyzed in this study, the Madeira and Port Santo Island groups. So the Manny-Whitney test was used. Regarding the results on demographics, a total of 42 data records were obtained from online interviews. However, one had to be excluded from the data records for the statistical analysis, owing to the fact that it was filled in by a plug-in hybrid electric vehicle user. A plug-in hybrid electric vehicle is a vehicle that has a combination of internal combustion and electric battery technology. So, a total of 41 data records were included in the analysis. There was significant difference in size from the two samples. Only 9.8% of the users are from Porto Santo, while 90% of the users are from Madeira Island. Regarding this issue, in this demographics section, the samples of Madeira and Porto Santo were studied as one. So, for a general overview of RAM sample population, we had 22% of the participants were female and 78% were male. Around 76% had a university degree. The sample average age is near 42 years old, and the annual income of the participants is higher than the average annual income of the Portuguese population. So, the results for the research question number 1, the main infrastructure uses charge EVs. The first results of these research questions were that under 66% of users prefer to charge at households, 32% at public charging stations, and 12% charge at work. We then analyzed 4 different questions that reproduced 4 dependent variables: the fastest, cheapest, comfortable, and public SOS, in order to understand if some of these variables are reasons to EV users to choose a specific infrastructure to charge their vehicles. In this case, the infrastructure group is the independent variable. In the first table on the right, shows that independent variables that are related to dependent variables are faster with household. This means that users that prefer to charge at households disagree with faster chargings. Faster with public charging stations. This means that users that prefer to charge at public charging stations agree with faster chargings. We had cheapest with household, cheapest with charging stations, public SOS and household, public SOS with public charging stations. When a significant effect was found in Kruskal-Wallis test, Spearman's correlation were used to measure effect sizes for variable comparisons. In the second table, we can observe that 2 significant correlations were obtained between faster and cheapest, faster and public SOS. This is because of what was previously mentioned before, that 2 opposite types of users, the households and public charging stations, have opposite opinions about charging EVs in a fast way, and that public charging stations must only be used at SOS cases. Regarding users' opinion about EV technology between Madeira and Porto Santo Island groups, we did not have a significant effect, so we analyzed this variable for the entire RAM sample. The pie chart plot reflects RAM's drivers' opinion about battery autonomy satisfaction. Nearly 49% of users are satisfied, 34% unsatisfied, and 70% do not have an opinion about battery autonomy satisfaction. Concerning the question about whether orography undermines the way that users drive DV, for both Madeira and Porto Santo groups, where 1 orography positively affects their drivings and 5 orography negatively affects their driving, the bar chart shows that the majority of the participants do not have an opinion in this issue. The test showed that there was no significant difference between the groups. The first explanation is the lack of participants from Portsanto being difficult to make a comparison between groups. Another possible explanation is the fact that a balance scale with 5 items was used, thus preventing a lack of balance in the response. Perhaps a 4-item scale would be a better choice, since it would force users to respond positively or negatively. So, we also analyzed other answers from the online questionnaire that were not directly used to answer research question number 1 and number 2, but might be of interest and users claim to use incentives for electric vehicles like Portugal government fund, RAM government fund, and brand incentives. We had that nearly 20% of participants mentioned not having access to a private car at household. Around 27% said that had to make changes at their household in order to charge at household. Users prefer to drive an EV instead of a conventional vehicle. 60% of the users mentioned they use strategies to maximize battery autonomy. Only 12% of the users never used the eco mode, and only 2% feels anxious about battery range. So, the results from our study can form a base for further research in information and communications technology for sustainability. For example, facilitate the charging of EVs at household. One of the key results of literature is that EV owners often prefer to charge their vehicles at home. Consequently, there is a need to devise smart charging strategies for EVs that involve not only the development of hardware, but also advanced software algorithms that can properly manage demand of the household and the EVs to be charged. It can also promote a fair and sustainable distribution of public charging infrastructures. One of the concerns expressed by our respondents is the fact that they do not have an EV charger in the household, whereas others don't even have access to a parking space where they can charge their EVs while at home. We consider that the government and industry representatives can have a crucial role by carefully deploying more public chargers, such that more people can own an EV. It can also promote the adoption of EVs beyond financial incentives. Our results also highlight the positive impact of financial incentives on the acquisition of EV. Therefore, the potential of ICT should be leveraged towards highlighting all the benefits of wide-scale adoption of EVs, such that, in the long run, the EV adoption is not halted by the drain of financial incentives. Last one, promote sustainable driving in EVs. Despite limitations of our study concerning the use of the RBS in flat versus highly road systems, we firmly believe that if appropriately used, this technology can lead to significant reductions in the electric energy consumption of EVs. Hence, there is a big opportunity for the ICT4S community to leverage existing research in eco-driving towards promoting sustainable driving behaviors for EV owners. So the main conclusions of our work: to answer our research question number 1, the manifest structures users charge their EV. Our hypothesis was denied, as we were expecting that EV drivers would prefer to charge at public charging stations, since they are free of charge, and refute what was stated by literature. For research question number 2, the effect of the orography, the results obtained between Madeira and Portsanto Island groups were not significant to analyze the data obtained, so there is still the need to continue studying the role of the orography in the driving experience of EV drivers and the contribution of this variable in the driving track condition in the RBS, and consequently in the EV technology. From the testimonials of our study, governmental incentives are considered an encouraging way to buy an EV in RAM. Some participants in our study stated that they do not have a private car to park their EV. Thus, in some cases, users need to first consider household car parking existence and household electrical grid infrastructure before purchasing the vehicle. The battery range anxiety mentioned in the related work did not seem to have a significant impact in Iran population. Our participants preferred to drive an EV instead of a conventional vehicle, so EV technology can be considered an inspiring technology regarding the obtained results, thus contribute to the reduction of greenhouse gas emissions into the transportation sector. And thank you for watching.